In this lesson, I'm going to go over how can I use the distributive property to write equivalent expressions. So you want to remember that the distributive property is what says when I do A times B plus C, I can rewrite that as A times B plus A times C, and it works the same with division, where I have B plus C divided by A. That can be written as B divided by A plus C divided by A. So this is what the distributive property says, and I'm going to go over 3 examples and how to use it with them. They're written here, so these would be the 3 problems you would write in the left-hand side of your 3-column notes. All right, to reposition some of my pictures here, I'm going to zoom in here and go into this first problem. You're going to take 6x plus 9 and try and put it into 3 equal groups. Your first strategy for this would be you could try Algebra Tiles, and I'll draw those real quick to represent the problem. Alright, so in this problem we have now drawn 1, 2, 3, 4, 5, 6, 7, 8, 9, so I have 9, and then over here I have 6 x's, 1, 2, 3, 4, 5, 6. So I want me to split them into 3 equal groups. So if I sit here and I'm like, okay, well if I know like 6, 3 equal groups would be 2, 2, and 2, so it would be 2x, and then the 9s, the 3 equal groups could be 3, 3, and 3, and that'll simplify my expression. I went ahead and did this again in more ones where I can move them around a little bit better. So you have 6x here, and I want to split them into 3, so I go 1, 2, 3, 1, 2, 3, so you can say I have 2x in each group, and then 1, 2, 3 with my 9s, 1, 2, 3, and 1, 2, 3. So then each one of these individual groups ends up being 2x plus 3, 2x plus 3, and 2x plus 3, which can actually be rewritten as 3 times 2x plus 3. Instead of adding all those up together, it's 3 times 2x plus 3, which if you worked it backwards to check it, you do the 3 times the 2x, you get 6x, and then you do the 3 times the 3, and you get 9. 6x plus 9, which if you come back here, is the original expression I had, and I divide it into 3 equal groups, which would be 3 times 2x plus 3. That's how you'd look at that problem, right here. Oops, right here. For this next example, we want to look at 3 times 2x plus 9 plus 6x into 3 equal groups. So when you're looking at this, you first could see that, oh wait, this is kind of already into 3 equal groups, 3 times 2x plus 9. So you'd have 2x plus 9, and you'd have that plus 2x plus 9 plus 2x plus 9. And you'd have those 3 equal groups there. And then you have to split the 6x, in which case I could put, an x here, an x here, an x here, another x here, another x here, another x here, and then I have 6x. So 1, 2, 3, 4, 4x plus 9 plus 4x plus 9 plus 4x plus 9. That's one way to look at this problem. My initial way to solve this one would be slightly different. I would start out doing 3 times 2x plus 9 plus 6x. Let's make sure I copy that. Yep. I'd start out and actually distribute the 3 times the 2x and the 3 times the 9. So 3 times 2x is 6x plus 3 times the 9 is 27. And then I would add in the other 6x, so I end up with 12x plus 27. And then I would go ahead and illustrate that using Algebra Tiles, and I could simplify it that way. But that's a lot of Algebra Tiles, so I'm going to pause the video and get them in there. Okay, so I think I made enough here, and let's go ahead and solve this problem. So you have 12x plus 27 into 3 equal groups, so 1, 2, 3. Let's zoom out so we can see it all. Oops. 12x plus 27 into 3 equal groups. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see how I'm doing this. I'm going to go ahead and pause the video and just show you how to get it. how I get it done with the x. Okay, so I've split the x's into the 3 equal groups, and as you can see, just like in my original total, I have 4 x's in each group. Now I have to split up the 27s. So I'm almost done splitting up these 27s here. I'm just going to kind of show you how I'm doing this. I'm putting them into 3 equal groups, these 27 ones, and I should end up with 9 in each group once I'm done splitting them equally. So this should be my last one. Yep, I have 27, 9, 9, 9. Again, if you know how to divide integers, you can really just sit here and say, what's 12 divided by 3? Well, 12 divided by 3 is 4x, and it's 27 divided by 3, well, that's 9, so 4x plus 9, because they're positive, and I just multiply that by 3. 3 times 4x plus 9 would be how to take this expression and divide it into 3 equal groups, and each equal group would be 4x plus 9. For this last expression, it is 3 times 5x plus 11 plus 7, and then divided by 5. So I would go with this one. It's not quite as simple as you're not multiplying by the 3 and then dividing by 3, you multiply by 3 and divide by 5. So I'm going to go through and actually distribute this 3 times the 5x plus the 11, and then combine that 7 with that once I distribute the 3. So 3 times 5x would be 15x, and 3 times 11 would be 33 plus 7. I can combine the like terms of 33 and 7 because they're both constants. 33 plus 7 is 40, and that'll be positive because they're both positive, plus, and you have 15x. 15x plus 40. Now I want to actually remember that I'm still dividing by 5, and then when I distribute, I actually divide the 5 into both the 15 and the 40. So as I come down, I do 15 divided by 5, x, plus 40 divided by 5, and 40 divided by 5 is 8, 15 divided by 5 is 3, so it's 3x plus 8 would be that expression simplified using the distributive property. So hopefully now you can answer the question, how can I use the distributive property to write equivalent expressions? And we'll have some more examples to practice with in class.